When you're given a quotient of powers, it's in the form of a number on top in the numerator and a number or a power on the top and a power on the bottom. And so this is essentially what a quotient of powers looks like. And before I get into how to solve that, I want to show you or remind you that when you were multiplying powers, it looked like this, right? 3 squared times 3 to the 6th power. And what you did was you took the 2 and the 6 and you added them together, and you found that your answer was 3 to the 8th power. So when you multiply, you added. Well, when you divide powers, you're going to do the opposite. Multiplication and division are opposite, adding, subtracting are opposite. So when you divide powers, the rule is to subtract. So 9 to the 20th power divided by 9 to the 15th power is simply 9 to the 20 minus 15, which is 9 to the 15th power. Oh, sorry, 9 to the 5th power. Sorry about that. So it's pretty simple. Assuming you subtract the right way, you'll be fine. So let's look at a couple of examples. First example says 8 to the 7th power divided by 8 to the 5th power. 8 to the 7th power divided by 8 to the 5th power. Again, all this is 8 to the 7th minus 5, and it becomes 8 squared. That's it. That's all you have to do, okay? For this one, same thing. The base is the same. You rewrite the base. You just take the exponents and subtract. This becomes 5 minus a negative 4. 5 minus a negative 4. You have to remember your integer rules. And if you do that, you'll remember that these become plus signs because you're subtracting a negative. And so it becomes 6 plus 6 is to the 5 plus 4, right? And 5 plus 4 is 9, so it's 6 to the 9th power. And finally, in the last one, y to the negative 10 divided by y to the negative 12. That becomes y to the negative 10 minus negative 12. Well, again, remember those integer rules. I told you they would follow you. These two signs, again, become plus. So in the last one, the example is y to the negative 10 over, or divided by, y to the negative 12. So what you're doing is you're writing the y, and you're bringing the exponents over, negative 10 minus negative 12, right? And what you have to do there is change the minus a negative to plus a positive, because it's keep, change, opposite, right? Equals y to the 2nd power, okay? So that's all we did there. You can see it was originally negative 10 minus a negative 12, and then I had to change it with the red lines to make it plus a positive. The next part is power of a quotient. Now, with power of a quotient, you have to remember that the exponent is on the outside of what's dividing on the inside. And when you have something on the outside of the parentheses, what you're actually doing is distributing to each number on the inside. So what you do is you're going to rewrite each number. 5, this becomes 5 to the 3rd power over x to the 3rd power. Well, now that's pretty simple to figure out. It's just 5 times 5 times 5 over x to the 3rd power would be x times x, right? Which ends up being just x to the 3rd power, so we really don't need to do anything with that. 5 times 5 is 25, times 5 is 125, and over x to the 3rd power, and that ends up being our final answer there. That's a 125 over x to the 3rd power. Let's do it again with this fraction. So 3 over x, or 3 divided by x, raised to the 4th power becomes, you're going to distribute this 4 to the 3 and also to the x. So it becomes 3 to the 4th power divided by x to the 4th power. So it becomes 3 times 3 times 3 times 3 over, now again, if we distribute x times x times x times x, we're going to end up back at x to the 4th power. So I'm just going to leave it as x to the 4th power. 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. So we have 81 over x to the 4th power. And that is our final answer there. So those are two good examples. Sometimes, if you notice, you have both of these are positive exponents, but sometimes you will get that negative exponent. And what we have to do is remember the first step always when you have a negative exponent is to get the reciprocal. So we're going to take everything here and we're going to rewrite it with a positive exponent. That's all we did was put this entire thing under 1. Well, now what do? Well, we keep the we keep the 1 there, and we distribute that 2, just like we did in the last problem, and it becomes x squared over 5 squared. And then in the next step, that becomes 1 over x squared over 5 times 5, which is equal to 1 over x squared over 25. And if you remember, what ends up happening here is this ends up flipping in our final answer because you're dividing by a 1. But if you want to see that, why that happens, it's because this line right here is division. So if I were to just rewrite it, keep everything the same, I would have 1 divided by x squared over 25. This right here is this right here. It's the same exact thing, just written a little bit differently. This division sign is replaced with this one. Okay, so if I have 1 divided by x squared over 25, I know with dividing fractions, I actually have to end up flipping, changing this, and flipping the second fraction, right? So your keep, change, flip, that's our rule for division. So you end up 1 times 25 over x squared, because you're flipping it, getting the reciprocal. And our final answer is 25 over x squared. And if you could remember in the future that whenever you're dividing a fraction into the number 1, your final answer is just going to be this fraction flipped. So there you go. There is the final answer, but all these steps in here kind of explain why that's the case. So go ahead, replay this video a few times. Make sure you can solve these problems on your own, and you should be good to go. Okay, practice.